Okay, we're back. Video number 2 for this week. We talked about central angles, but now we need to talk about something called inscribed angles. So what's the difference? Well, central angle, as we learned, is an angle whose endpoints are on the circle and the vertex is on the center of the circle. And the measurement relationship we learned here is that whatever this angle measurement is, it turns out to be the same as the arc that it intercepts. Very handy. An inscribed angle is different than this. This is a central angle, vertex on the center. An inscribed angle, we still have endpoints on the circle, but instead of the vertex of the angle being at the center, the vertex is actually over here also on the circle somewhere. And this is called an inscribed angle. But we still have an angle that's intercepting an arc. So the question becomes, is there a relationship between this angle and this arc? And there is. So if this arc is x degrees, turns out that the inscribed angle is exactly half as much. Okay, so one of the things I notice when we get to this section of this unit is that students get these two things confused, or they get them mixed up. It's real important that when you're looking at a diagram, ask yourself, am I looking at a central angle? Is the angle on the center of the circle? Or am I looking at an inscribed angle where the vertex is on the edge of the circle? Because the relationship, of course, here is going to be different. So, looking at a few examples of this, we'll look at some easy ones to start. So let's say we're given this picture and we're given this arc measure of 86, and I want to know, well, what's the measure of this angle? Well, this is an inscribed angle. The vertex is on the edge of the circle. The arc is 86. That means this angle measurement will be half as much, so this angle must be 43 degrees. Or in other words, I could say angle A is equal to 43 degrees. We could go the other direction, right? So let's say, excuse me, not the other direction, but just looking at like an obtuse angle. This is kind of a strange looking inscribed angle because it's so wide, but this is still an inscribed angle, right? Because we have endpoints on the circle and the vertex is on the edge of the circle and it is intercepting this arc. It's just that this time it's a major arc of 246 degrees. The relationship here will still hold though. This inscribed angle will be half the measure of the arc that it intercepts. So half of 246 is 123 degrees. Okay, these diagrams can get a little more involved. So let's look at these two examples here. Now here's something we should think about for a moment. Right here I have a diameter again, exactly half of the circle. So I know that this arc right here, which is exactly half the circle, is going to be 180 degrees. Notice that this angle right here is an inscribed angle that intercepts that arc. So if this arc is 180, this inscribed angle here must be half as much. This must be 90 degrees. So right there, I already know that x is equal to 90 degrees. That makes solving the rest of this problem pretty easy. If this is 90 degrees and this is 39, now I can certainly find y. So I can subtract 90, subtract 39 from 180 because I'm looking at this triangle now. And so y turns out to be, let's see, 90 minus 39, that would be 51. Okay. Let's look at this last one. So here we have a lot of chords and lines. Notice that this point, this intersection point right here, it looks like it might be near the center of the circle, but we're not told that. Okay, so we cannot assume that this point here is the center, the way we can in other diagrams if that center is marked, right? So we know this is a diameter. We don't have any known diameters in this picture. But we have some other things here. We have several inscribed angles. So let's see what we can figure out here. Take a look at this inscribed angle right here. Try to ignore everything else and just look at angle PRW. We know this angle is 58 degrees. This is an inscribed angle that intercepts this arc PW. So that means this arc must be twice the measure of this angle. So this arc out here has to be 58 times 2, or 116 degrees. Now, this is actually going to give me a way to solve for x, because look at this angle marked x right here, angle PMW. This is an inscribed angle that also intercepts this arc. So that means if I know this arc is 116, this inscribed angle must be half as much. So this angle right here is also 58 degrees. So already I have x. The last thing I need to do is solve for y. I'm actually going to use triangle properties to do this, right? So now just focusing on this little triangle I have right here, I can fill in this third missing angle, right? So I know that I can take 180, I can subtract 29, I can subtract 58, and we'll get 93 degrees right here. This is a vertical angle, so it's also 93 degrees. And look, now I can solve for y. Now I'm taking 180 and subtracting 93 and subtracting 58, and we get y, which is 29. Same three angles here, same three angles here. These two triangles would actually be similar triangles. So you can see how we can combine our knowledge of triangle properties, angle properties like vertical angles, and now we're combining them with inscribed angles or perhaps central angles to fill in missing arc measurements or angle measurements. You'll find I've posted a practice worksheet for you guys to do this week that has several problems involving tangent lines, central angles, and inscribed angles. Feel free to come back to these videos as you need to. Email me if you have any questions. And as always, have a great week. Stay safe, stay healthy. I miss you all, and I will talk to you next week.